All right. Well, it didn't count me in, but I'm going to assume it's working because I can see my face in the corner of the screen. So let's get started. Today, I just tried to scroll up using the mouse when it's paper. Today, we're going to talk about conditional statements, and that is our topic. Make sure you put your name, the date, and your class period on there. And we'll just dive right in. A conditional statement is a statement that can be written in if-then form. And we would write it in math as P and then an arrow and Q. And we would read that as if P, then Q, or P implies Q. The first part of the statement, the P, is your hypothesis. Immediately following the word if. And the second part, the Q, is your conclusion, which follows then. So if you are given a statement, a conditional statement, like if you live in Nashville, then you live in Tennessee, you can identify the hypothesis by finding, okay, the word if, hypothesis is going to be what's right after it. So hypothesis is you live in Nashville, and your conclusion is going to be whatever comes right after the word then. So that's you live in Tennessee. All right. Pretty straightforward, hopefully. Next, we'll look at another one. If the sum of the measures of two angles is 90 degrees, then they are complementary angles. So, hypothesis, it's a long one. The sum of the measures of two angles is 90 degrees, then they are complementary angles is our conclusion. All right, last one is if a quadrilateral is a square, then it has four right angles. Hypothesis, a quadrilateral is a square. Conclusion, it has four right angles. All right, so then we can write conditional statements if we're given a non-conditional statement. So here we've got an obtuse angle has a measure greater than 90 degrees. So to put that in if-then form, we'd start with an if. So if an angle is obtuse, notice how I had to rephrase my sort of hypothesis to be grammatically correct. Then its measure is greater than 90 degrees. So it's not an exact copy and paste. We do have to do some adjusting of the way it's worded to make sure that we have still a sentence that makes sense, because if an obtuse angle then has a measure of greater than 90-degree angles, doesn't make sense. And even if I hadn't added extra words in, it still wouldn't have made sense. But the way that I've written it, if an angle is obtuse, then its measure is greater than 90 degrees. That does make sense. Hopefully. All right, number 5, all numbers divisible by 4 are also divisible by 2. Right, so if a number is divisible by 4, then it is also divisible by 2. All right. So the next one, states on the East Coast border the Atlantic Ocean. So if a state is on the East Coast, then it borders the Atlantic Ocean. Barely gonna fit. Ocean, just right over the edge. All right. Next one, Valentine's Day is in February. So Valentine's Day, February. If it is Valentine's Day, then it is February. Okay. Last one is prime numbers only have 2 factors, 1 and their self. So prime numbers only have 2 factors. So if a number is prime, then it only has 2 factors. One and itself. So again, just taking the information we're given and rephrasing it into an if-then form. And that's all we have to do on this page. So I'll give it 3, 2, 1, and flip. Okay. We're going to talk about the inverse, converse, and contrapositive. These are all related to the conditional statements. That's why they're on the same notes. So the way that we're going to think about this, the inverse is formed by negating the hypothesis and conclusion. So that means taking the not of each part. So not P implies not Q. The converse is done by switching the hypothesis and conclusion. So instead of P implies Q, it becomes Q implies P, not Q. There we go. And the contrapositive is what you get when you smush them together. You do the negation and the switch. So not Q implies not P. There we go. So for these next 3 problems, we just need to write the inverse, converse, and contrapositive for the given conditional statement, and then determine the truth value. So if it is Saturday, then there is no school. That is a true statement. The inverse would be if it is not Saturday, then there is school. Yeah, because the opposite of no school is yes school. The opposite of Saturday is not Saturday. So if it is not Saturday, then there is school. I can think of a few examples where this is not true, such as on Sundays, which means that this is a false statement. And our counterexample would just have to be Sunday. We don't have school on Sunday. For the converse, we're just going to swap them around. So if there is no school, then it is Saturday. And in fact, we did just have days where there was no school and it was not Saturday. So this one is also false. And again, Sunday is a good counterexample. You could also put like Labor Day. That's a Monday that we don't have school. Things like that. The contrapositive is when you negate and switch. So if there is school, then it is not Saturday. Right? And this one is true since there is never school on Saturday unless you're like in college, but we're talking about high school. This one is true. If you don't have school, it must not be Saturday. Or if you do have school, it must not be Saturday. All right. Next one. This one's going to require a little bit more reworking the words, but still should be manageable. If the product of two numbers is odd, then both numbers must be odd. So our inverse, we're just going to negate both parts. If the product of two numbers, and we could say is not odd, or we could say is even, because even and odd are opposites with no overlap. Then both numbers can't be odd, right? So the opposite of both numbers must be odd is that at least one is not odd. So it could be that one is even and the other's odd, or it could be that they're both even. But they just can't both be odd. And the truth value of this, if you multiply any two numbers and you get an even number, at least one of the numbers you multiplied has to be even. So this is a true statement. For the converse, we're going to switch our original clauses. If two numbers are both odd, then their product is odd. So anytime you've got two numbers that are both odd, when you multiply them together, your answer is going to have to be odd as well. And this is also true anytime you don't have an even number going in, you won't have an even number coming out. So true on that for multiplication. And the contrapositive, so we're negating and switching. If two numbers are not both odd, then their product is even. So anytime you multiply in an even number, because that number is divisible by 2, whatever you multiply it by, the product you get will also have to be even, divisible by 2. So this is also true. You might notice here that we had false, false for inverse and converse on number 9, but we had true for all three on number 10. Contrapositive, you'll see, is true and true. So we might start thinking, okay, inverse and converse, not always true. Contrapositive might always match, but we'll do one more example just to see. If the temperature is 25 degrees Fahrenheit, then it is below freezing. Freezing in Fahrenheit is 32. I thought that this was common knowledge, but I guess it's not as common as I thought. Anyway, If, for inverse, the temperature is not 25 degrees Fahrenheit, then it is not below freezing. And this one is false. Since freezing is 32, any number less than 32 degrees Fahrenheit is going to be freezing. So you could say 20 degrees Fahrenheit or 30 degrees or negative 100 degrees. As long as the number you put is less than 32, it is a valid counter example. Our converse, again, we're just switching for the converse. If it is below freezing, then the temperature is 25 degrees Fahrenheit. And again, lots of numbers less than 32, so this one is also going to be false. And you can use the same counterexample you used up there, or any other number that is less than 32 degrees Fahrenheit. Last but not least, we have the contrapositive. So we're going to negate and switch it if it is not below freezing. Then the temperature is not 25 degrees Fahrenheit. And this one is true if you give it a minute, think about it. If it's not below freezing, the temperature definitely can't be 25 degrees Fahrenheit because that would be below freezing, which would make the first half not true. So it's true on this sheet, and it is true in life that the contrapositive will always have the same truth value as the original conditional statement, but the inverse and converse could be different. I think it's possible for like one of those two to be the same and the other one to not, but I couldn't tell you an example right now, so we'll leave it at that. And we'll see you for the next one well, I'll be doing it in 1 minute, but you might do it later.